You know, I told you to prepare yourself for class. I know you're ready wherever you are. So we are taking off with the first topic in physics, SS1 topic. If you miss, I would like you to follow up this teaching, even if you're in SS3, especially if you are not really flowing with your teachers. The reason is that you might have missed this particular topic. Without this topic in physics, you find it difficult to solve any mathematics in physics. So wherever you are, you just have to follow the teaching till the end. And the topic is units and measurements. Units and measurement. Matter, interaction of matter, that is matter, how matters relate. You know, matter is anything that has weight and occupy space. That's the simple knowledge of matter from your secondary school, junior class. You learn it. Do you understand? Yes. Now, the interaction of this matter is what is physics. That is all about physics. How they interact, the quantities, you measure how things they behave, and as in the rate at which. Do you understand?
Yes, ma'am.
Okay. Now, measurement is very, very crucial in physics. Measurement is very, very crucial in physics. Everything you measure, the unit must be there. Do you understand?
Yes, ma'am.
It must be specific, and that's why the unit has to come in. Now, from this measurement and unit, we are going to a kind of go around the whole physics, especially mathematics aspects. Okay?
Yes, ma'am.
So once you know how to draft, you know the unit of a quantity, and you know how it is being measured, then definitely you know the cost, you know the topic. You know the topic. And to solve questions, like especially mathematics questions, when you have this good knowledge of measurement and the unit, is easy. Okay, so you have to follow it. So I'll start from, what do you measure? I told you that is matter. Do you understand?
Yes.
What do you measure? Before you talk of measure, you are trying to ascertain a particular quantity. You're trying to ascertain what? A particular quantity. Do you understand? That is measurement. Now, I would like you to know, you will now know that quantity is not just what you can carry like this. Everything, there is quantity. Do you understand? There is quantity of everything you do, and that is all about physics. Okay, then before I go further with my measurements and units, I'll start with what you want to measure, which is what? Quantity. Which is what?
Quantity.
Quantity. Quantities. Now, we have two quantities. We have what?
Two
quantities in physics. We have derived quantities and we have fundamental quantities. We have two quantities, derived quantities and fundamental quantities. Now, what is derived quantity? What is fundamental quantities? Fundamental quantities are those quantities that are not that are independent. They are quantities that you measure with direct instruments. Do you understand? That is quantity. Like now, length. Length. When you want to get your length, you just measure it straight and you get your answer with a particular instrument. When you want to measure your, electric current, is just with the straight instrument. You are not driving it anywhere. Okay, something like mass is fundamental quantity. These are the fundamental examples of fundamental quantities. I say we have two quantities. One, fundamental and derived quantity. Okay, let's go to fundamental quantity. Quantity. Okay, so these fundamental quantities, you see, we did not drive it from anywhere. It's just the unit, and the unit is what? Abbreviation. But derived quantity, I'm going to show you how you drive the quantity. Do you understand? Now, every other quantities you're going to see in physics is derived from these particular quantities that I'm going to mention to you now. Okay? So I'll show you the fundamental quantity now. Then we'll go to derived quantity. Then we'll spend some time there, because there I will tell you the dimension and everything. And by then, I will also tell you how you are going to go through your new school physics and get me the drive the quantities you are going to see there. Okay? So now quantities. Number one, length. One of the fundamental quantities is what? Length. This is a length. Do you understand? In physics, this is a length. This is a length. Anything straight is a length. Do you understand? Anything you want to use your metal rule to measure straight is a length. This is a length. So once I measure it, I don't need to drive anything to show me the quantity. I will see it from the meter rule. Are you getting what I'm saying? I'll see it from what? The meter rule. So I'm not driving it in. That is why he answered the fundamental quantity. Every other quantity depends on this fundamental quantity. Now the unit of fundamental length is meter. Is what? Meter. This my meter rule is in cm, right? Yes, but SI unit, use SI unit in every measurement. Reason so that you can get other derivation that you want to get from it. Okay? So the SI unit of length, or this length, is what? Meter. Is what? Meters. So meter. In your questions in physics, you are not going to see them write 20 meters. You will not see it. You will not see what? Where they will write 20 meters. But whenever you see 20 m, that m is what? Meter. Is what? Meter. So the abbreviation is what they will use. And that's why I have to introduce the abbreviation. So the abbreviation for this meter is what? M. Is what?
M.
Is small m. Is what?
Small
m. Okay. Then another one is time. Seconds. The abbreviation of second is S. Is what? S. They are not going to tell you they're not going to tell you 20. In some cases you see 20 seconds, but most cases you see what? S. So whenever you see a number attached S, or when they say time is 20 S, it means 20 seconds. There are other units. I'll still tell you the other, but we are working with SI units now. Okay? So we have seconds for time. Okay. The next one is mass. Mass is the number of substances that make up what? An object or matter. That is mass. Do you understand?
Yes.
Like now, this is made of rubber. Okay? This is made of what? Rubber. So the element that makes up this rubber, the quantity of element that makes up this is the mass. Is what?
The
mass. So the unit of this mass is in kilogram. The SI unit is what?
Kilogram.
Kilograms, kg. It's in kilograms, kg. Electric current. Electric current is ampere. And the unit is what? A. So these are the examples of fundamental quantities. Temperature measured in Kelvin, the unit is Kelvin, the application is K. Amount of substance, mole, and MOL as the abbreviation. Then length, meters, M. Time, second, S. Mass, kilogram, kg. Electric current, ampere, A. Okay? So these abbreviations is what you be seeing in your questions, often in your questions. Okay?
Yes.
Attached to the value that will be giving you all through your work in physics. Okay?
Yes, ma'am.
So having known this, now we go to derive quantities. So you just have to have all these things in your mind. Do you understand?
Yes,
why we go for derived quantities? Because all the derived quantities, we are going to get it from here. Either combination of two or combination of one and the other. That is how we are going to go about it. Okay?
Yes.
And we get our derived quantities. So let's go to next topic, derived quantities. I told you that derived fundamental quantities are those quantities from which other quantities are based on. Now, these derived quantities are those quantities that use those fundamental quantities as their base. They are derived by the combination of fundamental quantities. Now, I'm going to show you how we get all those quantities. I'll give you the one I have here, then the assignment I'll give you, you go throughout your physics, any quantity you see there, you try to derive it from the questions. From the question, you try to drive the quantity. Do you understand?
Yes,
you try to get the quantity, or from the unit of the final answer, you try to get the quantity. You try to drive it and get the dimension. Okay?
Yes, ma'am.
If you are able to do this thing now, you find out that you will not find it difficult to form any question form any equation out of any question that will be given to you in physics. Okay?
Yes, ma'am.
You will not find it difficult with any calculation in physics if you are able to get this. Okay? Once you read the question, you'll be able to form the equation yourself. Okay?
Yes, ma'am.
Okay, that is why you have to do this assignment I'm giving to you now. Wherever you are, after today's lesson, just go through your physics, try finding the dimension of quantities you see there. Okay?
Yes.
Then if you have question, you can use our WhatsApp number on the screen. We are waiting for you. Now, quantities. Derived quantities. What are those derived quantities? I'll start from areas. The abbreviation for area is A. Is what?
A.
A. This A that you are going to see here is the abbreviation for area. It represents area. You're not going to, when you see 20A, it's not 20 area. Do you understand? This 20A, especially when it's talking about electricity, is ampere. I'm trying to differentiate something. But in some areas, the question will come, the area A or A equal to, then you now know that you are talking about what? Area. Did you understand the
Yes,
so it's not when you see 20A, you now say 20 area. It's 20 ampere, especially when you are talking about electricity. But when you hear that the A equals to, are you getting what I'm saying?
Yes,
20A is, this A now is the unit of this 20. Are you getting what I'm saying?
Yes,
but A is now the substance. Do you understand?
Yes,
that is measured and the answer is. Are you getting what I'm saying?
Yes,
so I want you to just put this in back of your mind. Area A. Now, the area, with the knowledge you have in your simple mathematics, the value, what the unit of area is meter square, right?
Yes,
Length times breadth. The area of a rectangle is length times what? Breadth. Okay, this is a rectangle now. Permit me to draw inside this thing because we don't have space. This is a rectangle. What do you use to measure here? This side. This is the length, right?
Yes.
This is breadth, right?
Yes.
Now, what do you use to measure this length? The instrument you use to measure here? Meter rule. And the same meter rule you use to measure from here to here.
Yes.
So two of them are length. Two of them in physics is what?
Length.
Do you understand?
Yes, ma'am.
So if you measure from here to here and from here to here, then the unit for the two is what? Meter, right?
Yes.
So because if you measure from the length is what? Length. Derivation of the quantity. Length times what?
Breadth.
Length times what?
Length.
Breadth. Length times breadth. So the unit of first length, which is here, is what? Meter. Times the unit of the breadth, which is what? Meter. And that is why we're able to arrive at meter times meter is what? Meter square. Okay? Okay, remember I told you that from here to here, I'm going down to dimension. From here to here is meter rule. We used to measure it. And because it's meter rule, we used to measure it, we call it what? Length. We call it what? Length. So, the dimension is, you are not talking of the unit. You are not talking about the quantity. I guess what I'm saying.
Yes.
If you are talking about dimension, you're talking about what? The quantity. So here is length and here is length. So our dimension derivation, how we drive, we use capital letter in dimension. We use what? capital letter in dimension. So what we have there is length 1 and length 2. So it's length times what? Length. This length of length width and length length. Length times length is what? L square. So the dimension of area is what? Capital L square. And the unit of area is meter square. Okay? The dimension of area is capital L square and the unit is meter square. I want you to just know this and keep it at the back of your mind, because by the time we go on in other calculations in physics, we'll be making use of it. I hope you understood this. Yes, if you have any question, you can copy your question by the end of the lesson. After you are through with the whole lesson, you can send us questions on our WhatsApp page. Number 2 is volume. We do represent volume with V. We do represent volume with what? V. Now there is a quantity in electricity that is V. Assuming you have 20 V, you will not say that it's 20 volume. No, it's 20 volts. But when you have V equal to, are you getting what I'm saying? Yeah. V equal to, you are now talking about the volume. You are talking about what? The volume. And especially when you're talking about, when the question is from magnets, it's not from electricity, they will always define it if they are talking about volume or they are talking about the voltage, even though the voltage is still V and this one is still V. So we use it to represent volume. We use V to represent volume. And this volume in simple mathematics, volume is length times height times what? Breadth. Length times height times breadth. So what do you use? What do you use to measure length times height times breadth? What do you use to measure the whole thing? We have length times height times breadth. Breadth. Length times height times what? Breadth. Okay. Now, what do you use to measure this? Meter rule. What do you use to measure this? Meter rule. What do you use to measure this? Meter rule. All of them are length. And the unit is what? Meters times meter times meters. So the unit is what? Meter cube. Meter cube. So when we go to dimension, L for length, length for times height, length for breadth. So this breadth, length times length is what? Capital L3. So this is the unit and this is the dimension of volume. Length times height times what? Breadth. Times breadth. So let's go to number 3. Hope you are following.
Yes, ma'am.
Okay. Let's go to density. Let's go to what? Density. Density is mass over volume. Density is what? Mass over volume. I'm giving you the literal explanation of all this. I'm going to take all these things are subtopics in physics. All these things are what? Subtopics in physics. You are going to see them treat area, you are going to see me treat volume, you are going to see me density as a topic, you are going to see velocity as a topic, you are subtopic, you are going to see all these things as subtopics. But how to measure them is what I'm teaching you now. So that by the time we get to those topics, you will not find it difficult identifying with our values there and making use of the quantities. Do you understand what I'm saying? Already you know how this volume, how meter square comes about and meter cube, length cube and length square. Are you getting what I'm saying? So you just note it and keep it. keep the knowledge, we are going to make use of it. I get what I'm saying. So I'm taking my time here so that you can now flow as we continue with other topics. Now, number 2, I said density is mass over what? Volume. Mass over volume. Mass over volume. Now, the unit of mass from the you can go to your fundamental quantity. What is the unit of mass? The unit of mass is kilogram. Right, okay. You just write kilogram over the unit of volume is what? The unit of volume is what? Meter cube. The unit of volume is meter cube. The quantity that form density is mass and volume. The quantity that form density is mass and volume. And then their unit, the unit of mass is kg, while the unit of volume is what? Meter cube. Okay. Now, go back to the knowledge of indices. Your knowledge of simple indices. If you have, permit me to write here before because of space. If you have A over B in indices, and you don't want to write it like this, you want to join two of them together. You want to have it as A, B. You are just going to carry this thing up and then write -1 because there is no number attached to it here. Do you understand? You cannot write 2 raised to power 1. 2 raised to power 1 is just like a 2. I get what I'm saying. So that we have B here, B raised to power nothing here. It means B is still the same thing as B raised to power 1. So when you want to write this AB together, you don't want to write it in this division form in indices. You are going to write it A B raised to power -1. So this B, as you are carrying it up here, you are going to identify what is B raised to power with minus sign. I get what I'm saying. Yes. So with that knowledge, if you have A over B raised to power 3, and you don't want to write it this way, you want to write it together, you write A B raised to power -3. Are you getting it? Yes. Okay, you have A B raised to power 5. Then you want to write together, you write AB -5, just like that. Are you getting what I'm saying? Yes, so we can come back here now. We have kilogram over what? Mass cube. So we want to write the unit just together. We don't want to write it per. You can write it this way. When you see this is kilogram per meter cube, okay? You can still write it the other way. And that way you write it is what? Kilogram. If you don't want to write it like this, you can still write it kilogram per meter raised to power -3. Kilogram per meter raised to power -3. So you call this in kilogram per meter cube. Kilogram per meter cube. So either this way or this way. Are you getting what I'm saying? Yes. So I use this to show you how the unit is being described. Okay, we'll now go to dimension. Mass. The dimension of mass is capital M. Is what? Capital M. The dimension of length is capital L. While dimension of mass is capital M. So we have capital M over the unit. This meter show that is length we measured, is it not? Yes. The volume is length times length times length, which is length cube. So this is our volume. That is length cube. Are you getting what I'm saying? Yes, ma'am. Okay, we can now write it just this way. M, capital M n raised to power minus 3. That is the dimension of density. Velocity is speed in a particular direction. When we come to motion, I'll explain it better. But I just want you to know what I mean by velocity. Now, velocity is displacement over time. It's over time taking. Now, I want to move from here. You know, as if you check your time, maybe 2:55. If I move from here to here, you check it, maybe 2:56. I get what I'm saying. So that 2:55 to 2:56 is the time I take to get to this place, right? Now, the displacement is the distance from here to here. I get what I'm saying, and that is velocity. I will explain more when we come to the topic proper. So displacement over time. Now, if you want to measure the distance, what do you use? Meter rule. You use what? Meter rule. So the unit here is what? Meter rule. Meter. The time you use your stopwatch or clock to measure it, reach it, and the unit of time is what? Seconds. So it's meter over what? Seconds. Remember your indices. You want to take this one here, it's meter per seconds, right? You want to take, you can write it this way, you can see it this way, or you still write it this way, meter per seconds, with the knowledge of your indices, right? Okay. Now, from here to here is length, right? So the dimension is what? Length. The time